Okay, let's talk about the function type. So for Python, functions are a type just like ints or booleans. We can check this with type, and we'll use our not divisible by function. We see that it's class function or type function. Why is this important? Well, because, and focusing on this part right here, we can use functions and pass them as parameters or arguments in other functions. Let's say f is a function. We can actually use this within our do something function. So in this case, we're returning f of a comma b. So we're calling this function, and this is actually this function is a parameter. So what it means is we could use add, for example. We could call on the add function in a parameter. So we could do something add 5, 6, and this would return that function call add of 5, 6. Try it yourself. What's the result of do something add 5, 7 or do something subtract 5, 7? Let's try, let's do the bottom one, subtract. So define subtract, return a minus b, and we'll define do something, which takes a function as an argument, also a and b, and it returns the call of that function with a and b as parameters. Let's try do something with subtract, and the arguments there are going to be 5 and 7, but we'll use the subtract function. We'll take these brackets out. 5, 7. It should do 5 minus 7. So what we're doing is we're calling a function within another function. Five minus 7 is negative 2, so this works. And you're going to find it's useful to use functions within other functions, but it's important to be careful here because you don't want to sort of have any errors in your original function because those can carry over into this other one. Let's talk a bit about how we can write larger programs in Python. So when you start looking into other people's code, you'll notice that they have, especially with Python code, they'll have Python files where they have lots of different functions, and they might import these files as modules and then use certain functions within those modules to do certain things. It's very vague, but what I'm saying is that these programs are large and there are many functions within them. How can you yourself create your own large programs? Here's some general advice, even though this isn't an exact science yet. There's still lots of research into this. Here's some general advice. Take your overall problem and break it into subproblems. So if you have to write a calculator program, for example, start thinking about what you'll need in your calculator program. Maybe you'll need to add two numbers, so you'll need an add function. Maybe you'll need to subtract two numbers, so you need a subtract function, and so on. And when you're actually making a function, I know when I write my function I'm just typing it out, but especially when you're dealing with new functions and you're not comfortable, it's important to follow a certain process so that you minimize the amount of errors you're going to get and you sort of are more efficient with your time. So one way we can do it, and this is how I sort of started, first define your function, give it a name, give it some parameters that you think you're going to need, and return 0, and just see if it works. This is just going to be an empty function, and you're just going to see, it's sort of like a shell, and you're just seeing if it runs and there's no problems. From here, you can just build a few lines at a time and just check to make sure that it's still working. So for this exact function, what we're doing is we're finding the color of a pixel given some image. Okay, so in this case we have image. We're using a certain module called PIL, and PIL has we can import image from PIL. So just like pandas, there are lots of different modules we can import which will help us do things in Python. So PIL, or you import it as image, can open an image, it can convert it to RGB, and so on. So we can check, does this function work? And we can keep building our function until it's done. And once one function is done, we move to the next one and the next one, and we continue until our larger problem is solved. And personally, how I find it very useful to do this, to take some larger problem, break it into chunks or smaller problems. And that's the way that I've personally found to be very efficient. If you don't want to do this, you definitely don't have to do it. It's just some general advice, and feel free to ignore it for sure. If whatever you're doing is working, then by all means continue to do that. This is just some general advice which is not supported by research, just a sort of opinion. So that's it, a bit of a lighter week. For the next class, what you're going to want to do is go through Chapter 6, and again, Activity 1 is going to be released, and it's going to be due by the end of the week at 11:59. So if you have any questions about that, again, feel free to email myself or the TAs, or to post questions on the forums. That's it for now. Have a good week.